Hello, welcome to another session of your chemistry classes. Today we will be discussing about displacement reactions. In last three videos we have seen the basics of chemical equations and reactions, how to balance the chemical equation. We have discussed about combination reactions and decomposition reactions. So in today's class we will be discussing displacement reaction, that is the third type of reactions in types of chemical reaction. Yes, you know me, I am Samjad Zakaria, chemistry faculty, Global Education Center. Welcome you all once again. Yes, so let's start. Those who have missed the last videos, please refer to it and you can come back to this video for continuation. Okay, fine. See, whenever you hear the name of displacement reaction, what comes to your mind? Yeah, something is getting displaced. Here, in chemical reaction, if a compound is given, one of the atom of that compound, which is present in the reactant, will get displaced by another element or an atom, or it can be an ion. Other ion or atom of an element displaces one of the compounds, atoms or ions. If Bc is the compound which is given, if A is an element's atom or ion, this A will displace an atom or ion from Bc. So A displaces B from Bc. So here A and Bc are the two reactants. Here A and Bc are the two reactants. Now this A displaces B from Bc to give you a new product. When A combines or A replaces or A substitutes or A displaces from Bc, it displaces B, then you will get a new compound or a new product which is a combination of A and C. A and C, and A removes or A displaces B from Bc, and B will get separated out and you will get the second product. So the reactions where such kind of chemical reactions happen are known as displacement reactions. So in short, displacement reactions are the reactions in which atoms or ions move from one compound to the other to form new compound. So atoms or ions move from one compound to form a new compound. Hence, these are also having the names of substitution reaction, single displacement reaction, or replacement reaction. Displacement reactions are known by three names: substitution, single displacement, and replacement reaction. This is the general equation. This is how displacement reactions are generally categorized as an equation. Okay. Now, the question is, will A displace B from Bc? When? Do all of your ions and atoms, do all of your ions and atoms, which is A, will it displace B? Or when it happens? For that, you have to learn in detail. Here, if A is more reactive than B, if A is more reactive than B, reaction takes place or displacement takes place. And if B is more reactive, suppose A is less reactive, B is more reactive, then the reaction will never take place. So I've said if A is more reactive than B, then A will displace B. If B is more reactive than A, then no reaction will take place. Now, how to understand whether A is more reactive or which element is more reactive than which element, suppose is iron more reactive than zinc or is aluminium more reactive than magnesium, how will you understand? For that, you have to follow reactivity series. Once you know the reactivity series, displacement reaction becomes easier for you, in which a given element will displace one of the atoms from your compound BC and it forms a new compound with A. Now, what is reactivity series or what are reactivity series? This is a reactivity series. Once at the end of the video, you will get a better idea of displacement reactions. Yeah, once the explanations are complete, you will be masters in writing the displacement reaction and writing the products of displacement reaction. Okay, now these are reactivity series. Reactivity series starts with potassium and here I have ended with gold. There are more elements. These are the most of the common elements which we use in our reactions that I have written. So how to remember this reactivity series? How to remember this reactivity series? See, I have underlined with blue. Each and every word you can see I have underlined with blue line. So it is, how will you name? So, camel. Poso, camel. That is the first part. Poso, camel. Okay. Poso, camel. Zintile. Poso, camel. Zintile. Poso, camel. Zintile. Haiko, Messigo. It is not Messi goal. Messi, any favorite, football stars out there? Yes. Poso, camel, zintile, haiko Messigo. Poso, camel, zintile, haiko Messigo. Now, potassium, K. Sodium. Camel, calcium. Mal, magnesium. Camel, aluminium. Zintile, zinc. Zintile second, iron. N, nickel. Tile, tin, lead. Hydrogen is taken as the reference atom. Hydrogen is taken as the reference element. Okay. Now, copper, mercury, silver, gold. Poso, camel, zintile, Messigo. Now, this is the reactivity series. Now, if my A is potassium, suppose A I have taken it as potassium, and B if I have taken it as zinc. C can be anything, it can be a salt, suppose zinc sulfate. Okay. A I have taken it as potassium, B I have taken it as zinc. Now tell me, is potassium more reactive than zinc? Is potassium more reactive than zinc? In reactivity series, potassium is above zinc, meaning to say that potassium is more reactive. So the elements which are at the top are more reactive. As you move down, the reactivity decreases where gold is having least reactiveness. Okay. Now, will A, I have written here, A is more reactive than B, then reaction takes place. Now potassium, is it more reactive than zinc? Yes. Potassium is more reactive than zinc, then the reaction will take place. And what you will get here? A will be potassium, you will get potassium sulfate, and zinc will get displaced. Zinc will get displaced. Here, atom of potassium displaces an atom of zinc, which meaning to say that more reactive atom displaces the less reactive atom from its solution. Important, from its solution. So more reactive atom will displace less reactive atom from its solution to give you AC plus B, that is potassium sulfate and zinc. Now if A I have taken it as iron. Okay, if A I have taken it as iron, and here I am taking calcium sulfate. Solution is calcium sulfate. Now tell me, will iron displace calcium? See, where is iron? Iron is somewhere here. Where is calcium? Calcium is in the top. Now, more reactive. A is less reactive than B. A is less reactive than B, meaning to say that B is more reactive. Will the reaction take place? No. If B is more reactive, the reaction will never take place. If B is more reactive, the reaction will never take place. Now, so A is more reactive than B, then reaction takes place. If B is more reactive, then no reaction takes place. No reaction takes place. Okay. Now, this is the reactivity series. Now, let's start with an example. Okay, let's start with an example. Here, I have taken a test tube. In that test tube, I have immersed an iron nail. I have immersed a iron nail. In that test tube, I have immersed an iron nail. The solution is copper sulfate, which is blue in color. And see guys, for 20 minutes, I am keeping the iron. Iron is nothing but what? Iron nail means it is Fe. I am keeping it in copper sulfate solution. That means, where is iron? Yeah, this Fe. I am keeping it in which solution? Copper sulfate solution. So, iron is top of the reactivity series, copper is below. Iron is at the top of the reactivity series, copper is at below the reactivity series. Now tell me, iron is dipped in the solution of copper sulfate. Now what happens after 20 minutes when you take iron nail? In iron nail, you can see the brown coating. So what is brownish coating? It is nothing but copper is getting coated. Copper is getting coated. And after 20 minutes, the blue color of the solution fades and you will get green color. Meaning to say that copper is displaced from the solution and iron sulfate or ferrous sulfate solution is produced. Ferrous sulfate solution's color is green. Blue color of copper sulfate fades and iron displaces copper from copper sulfate solution. Why? Because iron is more reactive than copper. Because iron is more reactive than copper, so iron will displace copper. Since A is more reactive than copper, iron will displace copper from copper sulfate solution. You will get iron sulfate and copper, which is green in color. Okay. Now, instead of iron, if you dip copper in iron sulfate solution, you are dipping copper in iron sulfate solution. Will the reaction take place? No, because copper is less reactive than iron. So always you remember which is more reactive, that metal or ion you have to put it in the solution. Which is more reactive, you have to put it in the solution. Least reactive should be taken as a solution. Least reactive metal should be taken as a solution. More reactive should be dipped in the solution. Now, so iron displaces copper. Copper is least reactive than iron. So copper sulfate is taken as the solution and iron is taken as the iron is dipped in the solution. So blue will turn to green. Now tell me, zinc and copper sulfate. Zinc is over here, copper is over here. So zinc is more reactive than copper. Zinc is more reactive than copper. So zinc will displace copper sulfate solution from copper from its copper sulfate solution. You will get zinc sulfate and copper will get displaced. Here you tell Ag and C1O3. Where is Ag? Yeah, mercury is over here. Copper. Mercury is over here. What about copper? Copper is over here. Now tell me, copper is above and mercury is below. That means mercury is least reactive. That means mercury is least reactive than copper. Now, if B is more reactive or if copper is more reactive than silver, will the reaction take place? No reaction takes place. So, your reaction won't be taking place. So, these are the basics of displacement reaction. Hope you understood this concept well. And yes, we will be continuing with double displacement reactions and redox reactions in the next videos. So, until then, bye.